All right, in the last example on this package, or on this topic, sorry, we are given a man drags a package across the floor with a force of 45 newtons at an angle of 22 degrees with the ground. The mass of the package is 10 kilograms and its acceleration is 3.5 meters per second. What is the coefficient of friction acting between the package and the ground? So the last thing we're going to want to find is the coefficient of friction. So we know that this man, he is dragging the package across at 45.0 newtons. That creates a 22-degree angle with the ground. With our angles, we have our x component, so our force applied in the x direction, and we have our force applied in the y direction. This here, what we've been doing, we call these vector addition diagrams. But remember, anytime we are talking with force, we also need to include a free body diagram. Using our free body diagram, we have our object. We have the normal force acting up. We have the force due to gravity acting down. We have our force of friction slowing the box down. And we also have this applied force. Now remember, we can take this applied force and instead of writing it this way, we can separate it into its force applied in the x direction and its force applied in the y direction up here, and the force applied in the x direction horizontally. That takes this force applied line and splits it into its two components. So with it split into its two components, we can now start to talk about what's actually acting on the object. We have F net is equal to what's acting on it, just like we do in our dynamics problems. So this force applied in the y direction and this normal force are going to cancel with the force due to gravity. Right? The package is not being lifted, it's not being sunk into the ground, it's staying right along the surface of the floor. So because of that, we don't include those. What we do include is the force of friction plus just the x component of the applied force. Remember, we've taken this and we've split it into its two components. So now we don't include this. We ignore that being there. So that leaves us with the force applied in the x directions. Those are the two forces acting on it in either way. So we have now the ability to plug into our formula. F net is mass times acceleration, and that's going to be equal to the coefficient of static friction times the mass times the acceleration due to gravity. That's for the force due to friction. That's review, plus the applied force on x. So if I'm going to rearrange this now, I'm going to rearrange mu mg is equal to ma minus the applied force. And we want to get that mu by itself. We're solving for the coefficient of friction. So we divide both sides by the mass and the gravity. So mu is equal to 10 kilograms times our acceleration, 3.5 meters per second squared minus our applied force in the x direction, which remember is our applied force, our total magnitude of our applied force. So 45.0 newtons times the cosine of 22 degrees divided by the mass, 10 kilograms, times the acceleration due to gravity, negative 9.81 meters per second squared. Alright, when we solve this and figure out our answer, mu is equal to 0.069. Alright, that's it for this topic. There is a your turn or a you try at the bottom here. This is up for you to do if you would like. I strongly recommend it, but once you're done these notes, you can move on to the next section.